Ever feel like LeetCode problems are a locked box and you've misplaced the key? What if I told you the key is right there in the problem statement, hidden in the constraints? Stick around and we'll reveal how to use this key to unlock the solutions to these perplexing problems. When you're tackling LeetCode problems, you will often see certain constraints specified in the problem. They're usually right there in the problem description, telling you the range of input values you can expect. For instance, let's say a problem states that n is less than or equal to 10 to the power of 5. What does this mean? This tells us that we need to design our solution to handle up to 100,000 elements. Now here comes the key part. Based on these constraints, we can infer what time complexity our solution should have. Here's how. In our example, an ON or ON log n solution will likely work within the time limits, as these would typically execute in a reasonable amount of time. However, an ON squared solution could potentially take too long, leading to a time limit exceeded error. How do I know that? Let's take a quick detour and talk about how coding challenge websites like LeetCode, HackerRank, and AlgoMonster execute your code. You write your code, hit submit, and voila, you get the results. But how exactly does that happen? Allow me to pull back the curtain and give you a glimpse of what's going on behind the scenes. You see, each time a user submits their code, a whole process is set into motion. The back-end code of these platforms springs into action and spins up something known as a Docker container. Think of it as a sealed-off sandbox environment, where your code can play freely without affecting or being affected by the host environment. Now, within this safe little sandbox, each of your test cases is run. Your code is executed inside the container, with each test case being fed as input. The output of your code is written to a local file. The platform then takes this output and compares it to the expected output. If the results of all the cases match the expected output, then you're in luck. Your code gets the green signal and is accepted. But what happens if your code takes too long? Well, that's where we have the concept of a timeout. Each of these containers has a specific timeout duration. If your code keeps running and running without a sign of stopping, eventually the containers will be shut down and you will get a TLE on the front end. Now you might be wondering, why are we talking about all this? Because this is where the constraints in your problem description come into play. These constraints are not arbitrary. They have a real impact on whether your code runs successfully within the container or times out. Based on our collective experiences and many hours spent solving problems, we've noted that the maximum number of operations generally allowed before hitting a timeout is about 10 to 20 million. Now that's a significant number, but how do we make use of it? We can use it to gauge the time complexity our solution should have based on the input size or n. Let me break it down for you. If n is less than 20. With such a small input size, we have a lot of room to work with. We can typically afford to use brute force solutions here. Why? Let's do the math. 2 to the power of 20 equals 1 million, which is well within our maximum operation limit. If n is up to 3,000. With this range, we're starting to push the boundaries a bit and will need to be a little more careful. An algorithm with a time complexity of O(n squared is usually the best fit here. An n squared operation for 3,000 still falls within our limit of 20 million operations. If n is between 3,000 and 1 million, now things start to get a bit tighter. An O(n squared solution is going to far exceed our 20 million operation limit. So we have to get more efficient, and that's where algorithms with time complexities of O(n or O(n log n come in. And finally, if n is more than 1 million, in this territory, even an O(n or O(n log n solution might be too slow. Here, we're going to need to pull out the big guns and go for solutions that have time complexities of O log n, or even O, 1. Let's look at a couple of examples. Before even looking at the details, we're going to jump straight down to the constraints. The constraint is 100,000, which falls in the O(n log n range. Let's check the solution, and it is indeed O(n time. Let's look at this other problem. The constraint is 200, which can be solved using n square solution. And this classic question merge sorted linked list. The constraint is 10 to the power of 4, which can be solved using an O(n or O log n time. Remember, these are guidelines and not strict rules. They're based on the typical performance of code running on coding challenge platforms and might not apply in every single case or to other contexts. However, they do provide a great starting point when deciding what type of solution to pursue. For a more detailed discussion, check out the link in the description. So the next time you look at a LeetCode problem, remember that there's a lot more to the constraints than meets the eye. They are your secret guide to cracking the problem open.